Hi, hello everyone. Good afternoon, मेरा बच्चा लोग कैसे हैं सब? How are you all doing? Okay, I think you might have already gone through the thumbnail, right? And the topic of today's class. Today, we are going to be continuing with our discussion on the numericals of the chapter Wave Optics. As I have told you in the previous class itself, right? It's a very important chapter. So doing the numericals from this particular chapter is super important, right? And this will help you to grab a lot many marks for all the examination which you're going to write, right? So let's build the confidence about this particular chapter of wave optics. Let's get started. But before we getting started, I know that many of you are thinking, right? Who is seeing me for the very first time? Who is this person? Ye kaun hai? Isn't it? So this is Ameer, your physics educator at Unacademy, and those who love me more, they simply call me Bhaiya. And before we get started, one more thing. Tell me, kaise hai mera bachcha log sab? How are you all doing? How are you all doing? Jyoti, hi, bad girl Sumita. And in the last class, matlab the class which we had on Sunday, right? I know that so many technical issues happened and we couldn't complete the classes. So whatever questions we have missed there, we'll be continuing from here. Okay, fine. Okay, jaldi aja, Preeti, jaldi aja. Okay, Abhishek, कैसे है सब बढ़िया? सुमिल, हाय. दिव्यांशु, अतुल, हाय, हेलो एवरीवन. सब बढ़िया है ना? सब मस्त चल रहा है. आई होप एवरीवन इज फाइन, एवरीवन इज हैप्पी, isn't it? Okay, awesome, awesome, awesome. So ठीक है. So let's proceed further. Those who want to know more about me, you can have a look at on the screen. Everything, whatever you want to know about me is given here. My experience, where I was working, for how long I have taught the students. Okay, everything is there. And more if you want to know about me, something personal, right? Okay, obviously, you can keep on coming to my classes, keep on talking to me, you will get to know more about me, right? Okay, ठीक है. So moving on. Now, if you want to get all the updates of all the classes that happens in our YouTube, you can be a part of Telegram channel. The link is given here and also in the description box. Okay, fine. Then Bugs Bounty, what is it? It's an amazing way which can help you to grab a lot much of prices. What do you have to do? You just have to go to the description. There you'll find a form. Fill the form if you are finding any inappropriate content in the videos uploaded by Unacademy. If it is valid, बहुत सारा prices मिल जाएगा मेरे बच्चे लोग, बहुत सारा, ठीक है? So don't miss this opportunity. Now, let me talk about the subscription plans and what all amazing features you can enjoy once you are a part of Unacademy subscription. In the meanwhile, you can all share the class to all your friends, ask them to join, jaldi se, ठीक है? Okay, fine. So if you are a part of Unacademy Plus subscription, you can get access to all the live classes, and if you miss any classes, a recorded version will be there. You'll be having access to that. Weekly test will be there. Okay, everything is being made in such a way, or the entire structure of this Plus subscription platform is in such a way so that your marks will be boosted just like that, your grades will be boosted just like that, and you will be seeing yourself a great improvement in your studies. Now, if you go for iconic subscription, you'll get all the features of Plus, okay, plus some extra features such as a personal mentor. Matlab, a person will be assigned to you. He'll be looking after all the academic planning things. Matlab, how much you have to study in a day. Okay, which all topics has to be completed. Okay, he'll be making the complete study plans for you so that you just need to follow them, and so that you can make the complete chapters and the entire revision before the examination. And obviously, that will help you in getting lot many marks, right? Then in iconic subscription, you will be given special light out solving classes, and so many other amazing things will be there. So don't miss all these opportunities, okay? So you can be a part of Plus subscription. If you go for 12 months, it should cost you 1,250. And as you all know, you don't need to pay that much because we have the code of AMB10, which will give you 10% of discount. Okay? देख ले. If you go for iconic subscription, मेरा बच्चा लोग, for 12 months it should cost you actually 2,333, but we don't have to worry, है ना? क्योंकि हमारा पास तो कोड है AMB10, use it, 10% डिस्काउंट ले ले, एंजॉय कर ले अपना जिंदगी, ठीक है? अरे यार, I'm really sorry, ठीक है? And if you have any doubts related to Unacademy subscription, what all things is happening there, what all courses you will be available, which all teachers are taking classes, any doubts you have, okay, you can get in touch with our counselor. The number for getting in touch with the counselor is given here. Okay, fine. Now, अरे जाओ भाई. Okay. Open house announcement. You know, open houses happens nowadays, right? You can get more close to your teacher. You can talk to the teacher also. So it is an amazing opportunity. Don't miss it. ठीक है. Now, you all know offer is going on. If you go for 3 month subscription, extra 1 month is given free. This is only available for the first 500 subscribers. So make use of it. Fine. That's all. Abhi, it's time for Wave Optics. Now tell me, chalo. How many of you are super ready with full of your energy for the session to get started? Everyone here. Who all are super ready for the session to get started? Jitna log hai? Good afternoon, Mithilesh. Hi, hello, Sumit. Khushali. Oh, everybody. Okay, no, this is not the question. I think these questions we have done in the past class, right? All these questions we have done in the last class. Till where we have done, ye bhi kiya hai. Okay, so we were going to do this particular question, isn't it? Right. So we'll start from this particular question. ठीक है? So yes, let's get started. Ready है ना सब? Shweta, Sumit, Shrishti, good afternoon, good afternoon. Good to have every one of you here. ठीक है? तो let's get started मेरे बच्चा लोग with full of your energy. अरे शुरू कर ले सर, शुरू कर ले. तो शुरू किया है पहला question. Go for it, everyone. Okay. So just start reading the question. Try to understand. And ये तो नन्नू मुन्नू क्वेश्चन है, सच में बताओ तो. Have you all started giving me the answers or what? I can see Mithilesh with A, Shweta with C, Sumit with A. C is like, sir, block C. Fine. Okay, so you just need to give the answers one time. That is more than enough. I can see it. Enough. Okay, Venom is also going for the option C or 3. Anyway, let's have a look. Everybody listen. In a Young's double slit experiment, waves of wavelength lambda are incident on the two slits in phase. They travel to a point on the screen to produce a second minimum of interference. The difference in the distance traveled by the waves is. First tell me, what do you mean by difference in the distance traveled by the waves? What do you call that? Array, difference in path, right? Difference in path length. So that is what you call it as path difference delta x, right? Delta x is asked to be found out here, right? So instead of asking directly what is the path difference, they have asked in a different manner so that they can confuse the students in a better way. इसीलिए the question is like this: the difference in the distance traveled by the waves, that is called as path difference, which is delta x. Now tell me, to a point where minimum happens, minimum matlab destructive interference happens, what is the general formula for the path difference? That is given by n minus half lambda, isn't it? Okay, the general formula for path difference to the point where destructive interference happens or where we can have minima point is by the formula of delta x is equal to n minus half lambda. है ना? ठीक है. Now they are talking about which one? Talking about second minima. मतलब the value of n is equal to 2 here. So delta x is equal to 2 minus half lambda. That is equal to 3 by 2 lambda. Delta x का value. सही है? So which is our correct answer? It's option A. I don't know why many of you have gone for the option C here, which is lambda. It's wrong, obviously, because question is about finding minima. Minima matlab where destructive interference happens. Where destructive interference happens, it's lambda by 2's odd multiples. We all know that. I don't know why many of you have gone for the option 3. Anyway, ये तो सही हो गया. I hope everybody got it. No doubts at all, right? है ना? Yes. Fastest. You were the fastest person to give. Mithilesh, very good. बढ़िया बात है. ठीक है फिर. So concept clear हो गया तो let's jump to the next one, right? Okay. So here we go. अगला question आ गया. जल्दी कर ले. ठीक है. So for this particular question, you will have to apply a bit of your concepts. Else it will be a bit hard to do it. So yes, go for it. Everyone try your best. Everyone, okay? Try your best. And let me see how many of you are going to give me the answer here. Okay, so Mithilesh and Jia already gave the answer. Areva. Okay, so both of them are going for the option C, which says 5, right? Okay, so anyway, let's discuss this. So someone was telling, Shraddha is telling, sir, आपका सारा questions का answer है A ही है. So I think you're going for the option A, right? Let's see your whatever method you have devised is correct or not. ठीक है. Anyway, let's do this. The largest number of possible maxima. How many maxima points? मतलब how many bright points obtained? How many bright points are obtained on the screen in Young's double slit experiment for double slit separation equal to double slit separation मतलब the distance between the slits, that is small d, is equal to twice the length of the wavelength. Okay, if this condition is being satisfied, how many number of bright points are actually formed on the screen when double interference slit happens? Okay, when interference happens, how many bright points are formed on the screen? That is a question. Shall we do it? Okay, everybody listen. I'll draw the figure and I'll explain it, or maybe a new space will be a better choice. Okay, what I'm going to draw is a small representation of Young's double slit experiment. Here we have the source, isn't it? Yes. So here we have our screen. This is our central screen. Okay, light will be coming from the source to both the slits, right? And wherever this undergo constructive interference, right, we will be having bright points. So bright points is obtained wherever we have constructive interference, right? And dark points are obviously obtained wherever we have destructive, but the question here is number of bright points formed. Okay, let's see how this question can be done. Let's say this distance is y. Y is the distance to some random bright point. What will be the formula for that? We all know y is equal to n times lambda capital D by small d. This is capital D, this is small d. So the distance to the nth bright point is given by the formula of y equal to n times lambda capital D divided by small d. Now I'm going to make a chotu changes here, or rearrangements. Let's say देख ले y by d is equal to n lambda by d. Is it fine? Yes. Now what is y by d? I am marking this particular angle as theta. Okay. So matlab we'll draw another figure. Which color will we use? Okay, let me use green or yellow is fine. है ना? ठीक है. Okay. From the center of the slits, okay, I'm drawing a line to the point wherever the bright is being formed. So I'm marking this particular angle as theta. Okay. Now देख ले y by d. Y is opposite, d is adjacent. है ना? Y by d can be written as what? Theta. Any doubt in that? Theta equal to n times lambda by chotu d. Right? देख ले. This is theta. Okay, theta is equal to, we have learned opposite by adjacent, y by d. So y by d equal to theta. Now we know that this angle will be very small, right? In usual cases, when angle is very small, we will use to write sine theta equal to theta, right? When angle is very small, we used to approximate sine theta equal to theta. So similarly, for this theta, I'm going to approximate this as sine theta. Sine theta is equal to n times lambda divided by small d. Okay, fine. Now we are asked to find out the number n value. The number of bright points that is being formed is a question, matlab n ka value. Now the relationship between this small d and lambda is given. What was it? Small d is equal to 2 times lambda. So small d is equal to 2 times lambda. This will cancel. Sin theta का value हो जाएगा n/2. Now, for finding the n value, which is the total number of bright points that is being formed here, we should also be substituting the value for theta. Okay, what is the value of theta? देख ले, we are having an infinite screen, let's say. Okay, infinite screen. Now, on this infinite screen, let's say so many number of bright points are formed, right? And the final bright point will be formed at infinity. Do you all agree with me on that? Right? The final bright point, right, will be formed at infinity. Now, if I draw the line to that infinity, कैसे हो जाएगा? Line to that infinity, this angle theta will be equal to 90 degree or not? If I draw a line from the center of the slits to the final bright point, which is formed at infinity, the angle will be almost equivalent to 90 degree. You all agree with me? Right? So इधर theta का value कितना हो जाएगा? 90 degree. So sine of 90 is equal to n/2, or n is equal to 2 times sine 90 is equal to 1. Which means the number of bright points formed above the central maximum is 2. इधर तो central maximum है, इधर one bright point will be there, इधर one bright point. That's what you mean by n का value 2 है, मतलब above the central maxima 2 bright points are formed. Similarly, we know that by following the same condition, 2 bright points will be formed below the central maxima also. Below the central maxima also, 2 bright points will be found, right? So together, how many bright points do we have? One is central maxima, which is a bright point itself, and remaining 4. So total, it constitutes 5 bright points. Is the concept clear? This is a very beautiful and a very great question. Okay, it's a very beautiful and a very great question with so many concepts hidden inside it. If you are loving it, means it's awesome, which means you are totally interested in this particular chapter. Fine. All good? ठीक है? Okay, once again fastest. Okay, you became fastest once again. All good. Mithilesh, awesome. Hi Shreya, hello. So any doubts, if anybody is having, ask me, or else you can copy down whatever it is being written here. You are the fastest, Jia. Okay, so seems like there is going to be a big fight here, right? Answer to it's 5. Was it option A? Let's check. No, it's 5. It's 5. The answer is not A, right? It's option 5 here. So I think your theory is wrong this time. Okay, right? ठीक है. So I don't find any, I'm not finding any doubts here in this class. So nannu munnu baat. So here we have another question, and for this particular question actually it is already there, right? One of the formula which we have derived in our class it is. So ठीक है, जल्दी से read the question and give me the answer. Everyone is going for the option. Mithilesh, Sumit, and Gia, I suppose, right? All of you are going for options D. Good, I say. Shall I read the question for every one of you? You can continue doing the problem, right? Until I do the problem and until I solve the problem here on the board, right? You all have the time. Till then you can keep on solving it and keep on giving me the answers here in the chat box. Okay, fine. Let's do it. Intensity of light at a point on the screen due to 2 coherent sources, right? Each having an intensity of I0 at the point and reaching the point at a phase difference of phi. Young's double slit experiment. 2 slits we have, right? From both the slits, coherent sources of light are coming, and both are having the intensity of light I0. Both are having the same intensity of I0. Now, if they are interfering at a point with a phase difference of phi. Okay, these two light waves, intensity I naught, interfering each other with an phase difference of phi, what is the net intensity going to be after interference? What is it? We already have derived the value. It is 4 I naught cos square phi by 2, isn't it? Those who don't know, those who can't believe this, they will write down the formula for net intensity. Matlab, in Young's double slit experiment, the waves of light or the light coming from both the slits are having intensity of I1 and I2. Okay, let's not say same intensity if they are having intensity of I1 and I2 before it when it undergoes interference. Okay, and if it is undergoing with a phase difference of phi, formula for intensity is equal to I1 plus I2 plus 2 root I1 I2 cos phi. Okay, two waves of light with intensity I1 and I2 and with a phase difference phi interfere. The formula for finding net intensity is given as such. For this particular problem, intensity the same hai. Matlab I1 and I2 are having the same value of I naught. So just we can substitute it here. So this is I naught plus 2 root of I naught into cos phi. Okay, this becomes 2 I naught. This also becomes 2 I naught into cos phi. 2 I naught is common. 1 plus cos phi. 1 plus cos phi का formula क्या है? 1 plus cos phi. 1 plus cos 2 phi. 2 cos square phi. Okay, so 1 plus cos phi will be equal to 2 cos square phi by 2. Trigonometric identity. You will be doing this better than me. So they declare 2 into 2 is 4 I naught cos square phi by 2. So instead of by hearting this formula, the best thing is to by heart this, because this will help us in finding intensity of the net intensity that is being formed if two light waves of different intensity I1 and I2 interfere with a phase difference of phi. Okay, so this is the general formula, and by using this general formula you can derive any kind of equations related to intensity according to the equation. Fine. All good? 4 I naught cos square phi by 2. Okay. Awesome, awesome, awesome. So badhiya, all good? Right? Okay. So let's move for the next question. मेरा बच्चा लोग अगले question के लिए हम जाएगा अरे आ गया हम अगला क्वेश्चन के पास हम आ गया है एंड नन्नू मुन्नू क्वेश्चन है, जल्दी से करके मुझे उत्तर बता दे, ठीक है? Who is going to give me the answer? Hello Vipu. Okay, Mithilesh, Jia, Sumit. Okay, the three musketeers, let's say, who give the correct answer so fast. Shweta. Okay, so whoever have given me the answer, it's option A. Others, continue doing it. ठीक है? It's fine. People will be having different speeds of doing and finding the solution is totally fine. Okay. A width of a certain interference pattern. Array, fringe width is given. How much? Beta is equal to 0.002 centimeters. What is there? Fringe width beta is given as 2 into 10 power minus 3 centimeters. Okay. Question is, what is the distance to the fifth darkest fringe from center? Tell me, what is the general formula to find out the distance to the nth dark fringe, to any random dark fringe that is being formed, how can we calculate the distance to that? Formula y is equal to n minus half lambda capital D by small d, isn't it? Right. Now, beta is given as 2 into 10 power minus 3. Okay, fine. Now, how can we calculate beta, which is the fringe width is lambda capital D by D. So, indirectly, they were actually giving us the value of lambda capital D by small d, so that it will help us in finding out the distance to the fifth dark fringe. So, y, the distance to the fifth dark fringe is equal to, substituting n equal to 5 minus half lambda capital D by small d is 2 into 10 power minus 3. So 10 minus 1, 9 by 2. Yeah, this 2 cancels. This is 9 into 10 power minus 3 or 0.9 into 10 power minus 2 centimeters. 0.9 we can almost approximate it as 1 into 10 power minus 2 centimeters. And by that approximation, we are having the value or option as 1. The correct value is 0.9 into 10 power minus 2 centimeters. Okay. So we'll get the first option only after approximation. मिल गया है ना? इतना बड़ा तो बात नहीं. Go through the question once again. Beta value is given and we are asked to find out the distance to the fifth dark fringe. For that, I have written the general formula to find out the distance to the nth dark fringe. As the question is about finding distance to the fifth, substituted n equal to 5. Okay, and lambda d by d ka value given as beta. Substituting that, we will get to the final answer. This is what we did. No doubts? So badhiya. Shall we move to the next one? Jaldi note kar le those who want to note. Jaldi, jaldi, fatafat. Jaldi, jaldi, fatafat. Okay. So moving on. Next. This is a very good another question. Next one, noted Sumit. Very good. So both of them are fighting for G and Mithilesh sir. Arre. If it was school class, I could have did this. I could have made both of them stand up from the bench and I could have did this. Arre kya kar raha hai? Abhi to I can't do anything, right? Mithilesh C bol raha hai, then Jia C. Okay, then Shreya C. Shraddha is going for the option D there, a different variety option there. Okay, so these are the common options I am able to find. कैसे करेगा? Young's double slit experiment using sodium light. Okay, lambda is 5898, 92 fringes are seen. When the wavelength used is 5898 Armstrong, 92 fringes are seen. Okay, on the screen during a Young's double slit experiment. Okay, if you are using another color, matlab a different wavelength, the number of fringes will be. So for doing this, we just need to find out the relationship between number of fringes formed and the wavelength. That's all. Or kuch nahi, or kuch bhi nahi. ठीक है? What is it? We all know the distance to the nth bright band is given by n lambda capital D by small d, right? So from here we know that n lambda is equal to a constant. How I got that? Because we are keeping the remaining things always as a constant, capital D. The distance between the slit and the screen, is it kept as a constant? Yes. The distance between two slits, small d, is it kept as a constant? Yes. Why? The distance from the central bright band on both the sides, why? That is also remaining as a constant, right? Matlab, the remaining three things remains as a constant, which says n lambda value will be a constant, which means n1 lambda 1 will be equal to n2 lambda 2. What is n1? Number of fringes 92, wavelength 5898, n2 number of fringes formed in the second case pata nahi, wavelength is known to us, that is 5461. So n2 का value कितना मिल जाएगा? 98, 5898 by 5461. 58 by 54 is a value greater than 1. So once you multiply that value greater than 1 with 92, this value of 92 will increase a bit, and if it increases a bit, there is only one option, that is 99. So that's our correct answer. So don't spend your time when you already have the answer A as one among the options, okay, by doing the entire calculation. Okay, do whatever is necessary. Here, will it be any helpful for doing the calculation? No, it will only take away your time. So 58 by 54 is a value greater than 1. So that value greater than 1 multiplied by 92 will be a value greater than 92. So the only option is 3, which is 99. Okay. अरे बोल दो ना जरा, जल्दी बोल दो हाँ सर बिल्कुल सही है ना? सब बढ़िया चल रहा है सर, सब आ रहा है सर, सब समझ में आ रहा है सर. So any doubts, anyone? If anyone is having any doubts, this is your time. Okay, Shreya, go and have some food and come back. Fine, we'll still be here. Next, yes, okay. Energy pura hai na? Tell me, how's the Josh? Kaise hai? Okay, how much energy you all are holding up for the class? Let me know here in the chat box. Is it awesome? Is it super great? Is the energy super great? Yes? Okay. So if that's the case, I can give you the next one. Why should stop you from doing the next one? Hai na? Yes, sir. That's the energy what I'm talking about. Vibhu got me the vibe, right? Vibhu got my vibe, and he's like, yes, sir, I'm totally ready. That's what I want. Jia with full of fire. Awesome. Go for and give me the answers anyone. Hi, Preeti. Good to have you back here. So, Mithilesh with option B here. Then Jia with option B here. Anyone else? Shelly Kaushik with option B. Okay. So, yes. Everyone already have given their answers, or many of you? Many of you are still doing it. It's awesome. Keep on doing it. And just check whether the answer you got and whatever I am going to explain is matching up. Okay, if there is any conceptual errors you find, please change your concept, because whatever concept you have learned, there is some mistake in it. Okay, so fine, let's see. A diffraction pattern. It's not interference. You can underline, it's diffraction. Due to a single slit has been obtained using a beam of red light. Okay, so whenever we are having the diffraction pattern, we were using a red light. Now on replacing the red light with the violet, what happens? Right? Instead of using red, now I'm going to use a violet light. In that particular case, right, what will happen to the entire diffraction pattern? Now, we all know that the angular separation, right, or the angular width of each and every bands formed in diffraction pattern is lambda by A, except the central bright, because angular separation of central bright is twice the angular separation of the remaining interference fringes or the remaining interference bands. Okay, so usually it's lambda by A. Whether you consider it lambda by A or 2 lambda by A, the answer for this is going to be the same. Anyway, देखिए, what we are going to do? We are going to replace a red light with a violet light. We know which one is having a larger wavelength, because in the equation we have wavelength, right? Because it is based on that we can compare the value. Now red is having a larger wavelength compared to violet, right? So if you move from a large wavelength color to a small wavelength color, right, wavelength decreases. When wavelength theta decreases, when wavelength lambda decreases, theta will also decrease. मतलब देख ले, diffraction bands, which means the fringes, right, it becomes narrow. Its width will decrease, and when its width is being decreased, obviously it becomes crowded, right? Because all the bands will be coming so close as they are shrinking. Because of what reason? Because of the change in wavelength from higher value to a lower value. Is it clear? Clear, Anna? So here we have the second option as the correct one, right? Superb. Okay, fine. Any doubts, anyone? कुछ भी नहीं, I suppose. Good question, है ना? Shall we jump to the next one? ठीक है, हम तो जा रहा है, बच्चा लोग जा रहा है अगला क्वेश्चन के लिए. This is also a very good question. Let me see. Oh, Preeti, I'm so happy to know that, and I'm so happy to be a part of every one of your studies. Awesome. Okay. Many of you are giving the answers so fast, right? Even before the question appears on this particular blackboard, I have no idea how it is possible. I hope you are taking this seriously and doing the problems, right? Okay, I'll say Mithilesh, Jia, option D. Shraddha is going for option C here. Okay, so Preeti is like D option is correct. Khushbu is like D option. Okay, so let's see how this question can be done. In an experiment of a single slit diffraction. So now we are talking about single slit diffraction experiment. The width of the slit is 1.2 micrometers. Okay, width of the slit matlab A ka value. We can write it here. A is equal to 1.2 into 10 power minus 6 meters, micro conversion. And half the angular width of central maxima is observed or equal to be pi by 6. Find the wavelength of light. देख ले, everybody listen to me here. Single slit, right? I'm drawing a line through the center of the slits and perpendicular to the screen like this. So let's say this is the entire width of the central maxima, okay? And I'm drawing a line from the center to the topmost part of the central maxima. This total angle, Anna, this total angle corresponds to the entire angular width of central bright. Okay, but is that given? No. What is given? What is given? Half the angular width of central maxima. So this is total. Itna angle hai na? Can you see? Can you see that angle which I have marked? I'll mark it. Dekh this much angle with the white color, that is actually corresponding to half the angular width of central maxima, and that theta value is given as pi by 6. Okay, now tell me, this central maxima or the central bright point of diffraction pattern will keep on extending till it reaches what? The first dark. Any doubt in that? After the central maxima is finished, what we have is the first dark point, isn't it? So we can also define theta as the angle from the center, to the point where first minima is being formed. Can we do that? Yes. So if that is the case, do we have a formula for that? Yes, we know A sine theta to the nth dark band in a diffraction pattern is given by a sine theta equal to n lambda. Here we are talking about the first arc. Okay, so sine theta is equal to 1 into lambda by a. Any doubt? No, right? Question is to find out lambda. Lambda is equal to a sine theta. A का value कितना था? A was 1.2 into 10 power minus 6. Written already. Okay. So theta का value is given as 30. So sine 30 is equal to 1 by 2. Okay. 1.2 by 2 is 0.6. 0.6 into 10 power minus 6 lambda, but is equal to lambda. But we want the wavelength lambda in which unit? Not in meter, Angstrom पे. So convert कर ले. 0.6 can be written as 6000 into 10 power minus 10 as lambda, right? So lambda is equal to 6000 into 10 power minus 10 is equal to Angstrom. So the value of wavelength here is given as 6000 Angstrom, which is option 4. Have a look here. Try to understand the entire concept. Any doubts you have, this is your time. Ask me, get it cleared. Nahi hai to you can just give me a smile here in the chat box. Sir, someone copy my answer, sir. Oh, then what you can do is like, why don't you take a copyright protection? Okay, from the court. So no one can do that. Okay. So today all answers are correct. Mithilesh, ठीक है? Awesome. So any doubts, anyone? I'm just looking into the chat box, not essay because of jobless thing, you know. I'm just looking if you have any doubts. I was looking at that. So I hope you all have copy भी कर लिया, है ना? हाँ सर कर लिया, आप अगला क्वेश्चन दे दे, है ना? That's what you're telling. ठीक है तो अगला क्वेश्चन तो दे दिया, करके दिखा, जल्दी से करके दिखा. It's good. Already I think many of you have started giving me the answers here. Gian, Mithilesh here, obviously, right? When is Unacademy app class? Now I'll be telling you. Tomorrow and day after we'll be having mostly. I'll be updating in the groups. Okay? So people are going for A and B options. Anyway, let's see. What happens to the angular width of the central fringe of a single slit diffraction if the slit width is doubled? Slit width hai na, which is A value. If we are doubling that, what will happen to the width of or the angular width of the central fringe in diffraction pattern? What we need to do for this? First, we need to write down the formula for the angular width for central fringe. Formula is 2 times lambda by A. So question is, what will be the new value of angular width of the central fringe? In which case, when this A becomes what? Twice. So that will be equal to 2D. A becomes 2 times A. So this is 1 by 2 into this 2. Okay, remaining is 2 lambda by A. 2 lambda by A was the initial value of theta. So the new angular width theta dash is equal to half the value of initial width, angular width. So which option? B, which says angular width becomes half. Nannu munnu, right? Anybody can answer this if you know the concept. Not a big deal at all. Yes, Mithilesh, आप सही बोल दिया, ठीक है, बढ़िया बात है, option B correct है. I think many of you have given, it's not a big deal doing this problem. right? हाँ हाँ, everyone is also agreeing with me. Sir, जो आप बोल दिए वो सही है, सिंपल डिम्पली है, ठीक है, सिंगल डिम्पली है, तो अगला क्वेश्चन पे जाएगा. Moving for the next question. Start reading everyone the question and start solving it. Okay, I'll read the question once for you. Have a look. Light of wavelength is incident normally on the slit of width. So only a single slit is there and width of that slit is given. What will be the width of central maxima at a distance of 1 meter from the slit? Matlab from the single slit, you are keeping a screen at a distance of 1 meter. In that's the case, what is the net distance of the central maxima? Not angular width is asked, right? The actual length of the central maxima is being asked here. So try to recollect the picture, right? Try to understand what is being asked here in this question. How many of you got it? Tell me how many of you got the method of doing this problem and the equation for doing this problem. How many of you got it? Okay, Preeti. Best of luck for your chemistry exam. Okay, go and rock it. Okay, so everyone is like A, sir, A, sir, A, love. Everyone is going for the option A. Let's see. Okay. Now, here in the question, they talk about the single slit diffraction pattern, right? Now, exactly at the center, what we have? Central bright. So the question is, if this much is the width of the central bright, this width y, if we are mark it, how much is it? Okay, we are asked to find out this width of the central bright. To what distance the central bright is being spread at? Can you see in the figure? And that y has to be found out. कैसे करेंगे? How to deal with it? Very simple. ये तो theta mark कर ले. Okay, the angular separation of the central bright, let's mark it as theta. We already know the formula of that. How much is it? 2 times lambda by a. And we also know that theta is equal to opposite side y divided by adjacent. So adjacent we can consider as the distance between slit and the screen, capital D, is equal to 2 times lambda by a. Question क्या है? Y. So y is equal to 2 times lambda capital D by small a. Start substituting. So y is equal to 2 times. How much is lambda? 600 nanometer. 600 into 10 power minus 9. Capital D. How much is it given? 1 meter. Which is this distance between slit and screen is given as 1 meter. The whole divided by A. A, what is it? Slit width, 0.2 millimeter. That is 2 into 10 power minus 4 meters. So shall I leave the mathematics to you? अरे कुछ नहीं है mathematics here. 2 cancel हो जाएगा, right? What do we have as 6? This 10 power minus 4 goes up, 10 power 4. This will add up. So 2 more zeros, 10 power 6. 10 power 6 into 10 power minus 9 is 10 power minus 3. So this is 0.006 meters. Okay, so if you know this particular concept and if you know to do the problem according to what is being asked, you will get the answer. Is it clear? Is it clear? सबको अच्छे से, नन्हे से मुन्ने से प्यारे से. It's very simple question. उतना तो simple नहीं है, but फिर भी. Okay. Yes. Yes. With full of energy आ गया है. Okay. Still there, holding that energy. अगला question तो आ गया. For those people with full of energies, the questions will be just flowing at you, and this is that question. So do it everyone. आराम से go through the question मेरे बच्चा लोग. Then try to understand what is said in the question. Then understand what has to be found in the question. Then make a plan in your mind, right? How can we get to the final answer? Okay, make the plan of all the steps and all the formulas to be used to get to the final answer. If you can do this systematically, doing any problem is not a big deal. ऐसे करेगा. Okay, ऐसे करेगा, ऐसे करेगा. Anyone give me the answer or what? Or should I be explaining? Mithilesh, Jia, Shweta, Ritucha, right? So everyone started to give. Let's see. In a diffraction pattern obtained in a single slit experiment, the width of the central bright maxima. What is the angular width of central bright maxima? 2 times lambda by A. Dash the width of other maxima. Okay, for the other maxima and minima, the usual value of angular separation is lambda by A. For the remaining bright bands and the dark bands, their width is lambda by A, but only for the central it is 2 times lambda by A, which is 2 times the width of what? 2 times the width of other maximas. Central maxima is having twice the width of other maxima. So we should be going for the option D or option 4 here. This is very important. But when we talk about interference, is there any difference in the width of the fringe? Is there any difference in the fringe width? Bilkul bhi nahi. Because in interference, right, throughout all the fringes, all the bands are having the same brightness and also the same thickness. So this difference is only obtained in where? Yes, in the case of diffraction pattern. सही है? Fine. So no doubts, I suppose. Shall we jump to the next one? Hooray, if you guys are like this, Anna, coming to the class, I know it's 2 o'clock, 3 o'clock, you might have just had your lunch and you would actually prefer sleeping out there instead of listening to the class and doing the problems. But still, just think, this time which you might be using for sleeping somewhere or being lazy, usually, right? Because nobody usually prefers to learn at 2 o'clock or during the afternoon time. Okay, so instead you can just lay down there, sit on a chair, and you are actually solving the problems for wave optics. How amazing it is, isn't it? Yes. So give enough importance for this, okay, and do the problem. So हो गई बात, अगला क्वेश्चन पे हमको जा सकता है, I suppose. तो हम गए. Okay, so everyone is feeling hungry at different times. सर आपने पता है मी करेक्ट आंसर क्यों? Okay, everybody kindly give the answers. There is nothing like somebody giving the answer fast or slow. I'm not just looking into that. Okay. Okay. So everybody take your time and do the problem. I'll be so happy for that. Okay. So Mithilesh is going for C, Gia for C. Then JSL with a B. Shali with okay. Shali said hi. Hi Shali. Okay. Hi everyone. So let's see which is our answer for doing this problem. देख ले. In an experiment of a single slit diffraction, right? The distance between the screen and the slit is increased by 5 centimeters. The angular width will. Tell me what is the value of angular width of any maxima or minima? Theta is given by lambda by A. This is the width of any fringes or any bands you take in a diffraction pattern other than the central maxima. ठीक है? Now, what is changing here? The distance between the screen and the slit, right? That is changing. But in the equation for theta, which is angular width, we do not have that distance. The distance between the slit and the screen is not there in the equation. Usually it is capital D, right? The distance between the slit and the screen is defined as capital D, right? Here in the equation for theta, which is angular width, we don't have D here. Matlab angular width is independent of D. So even if D changes, theta, which is the angular width, will not change. So which one? It remains a constant. It will not change. So it is going to remain as a constant there. आ गया. Afternoon in era. Shraddha, yes, it was option C. Okay, fine. All good? No doubt from this particular question, I suppose. Okay. So yes, let's get proceeded to the next one. So this particular question is the combination of both interference and the diffraction. कौन कौन दे देगा उत्तर? सही उत्तर आफ्टरनून. जैसल, you look handsome sir. ठीक है, बढ़िया बात है, thank you. Okay, Shraddha is going for option D there. Okay, anyway, let's solve it, right? Solve करके हम देखेगा. My legs were paining, that's why I was sitting. Okay, everybody listen. It's a very good question. ठीक है? What should the width of each slit be? मतलब the width of each slit, A. That was simple, we used to express that, right? Slit width, A is the question. To obtain 10 maxima of the double slit pattern within the central maxima of the single slit. What does it say? Inside one central maxima of diffraction. Okay, you know the point on the screen where the central maxima of diffraction is formed, right? So inside that, if 10 maximas has to be formed, okay, 10 10 bright points of interference has to be formed. If that case has to be satisfied, A का value कितना होना चाहिए? Okay, so inside one central maxima of diffraction, 10 maxima of interference has to be formed. If this case has to be satisfied, question is what is the value of A? Okay, tell me how can we do? 10 maxima point. Tell me what is the width of one maxima point? That is equal to lambda capital D by small d. Now what will be the width of 10 such maxima? 10. So the total width of 10 maxima should be equal to the width of the central maxima. What is the width of central maxima? 2 lambda by A. This is angular width, multiplying it with capital D, which is the distance between the slit and the screen, will give us what? Right, the total width of the central bright of what? Of diffraction. Okay, so you can have a look at it. Whatever it is, cancel lambda d cancel. 10 by 2 क्या हो जाएगा? 5. So 5 by d is equal to 1 by A. So d is equal to cross multiply, that is 5A, and A equal to d by 5. Isn't it? Yes or no? Yes. So d is 1 millimeter. 1 millimeter divided by 5 is 0.2 millimeter. Not a big deal, right? So we have the correct answer as option 4 here, which says 0.2 millimeter. सही था, है ना बच्चा लोग? उतना तो it was not such a difficult question. Now when I explained you, I hope you all got it, isn't it? We have 10 maxima of the interference has to be formed inside the central maxima of diffraction. So if this condition has to be satisfied, the total width of 10 maxima in interference, that is 10 lambda d by d, should be equal to the width of what? The central maxima of diffraction. Formula is this. Cancel kar le, rearrange kar le, get the answer. That's it. Okay. Yes. सही है. So next one. So let's do some question from polarides and all. ठीक है. Let's see who all are good in this. I'm here only. ठीक है. मैं इधर ही हूँ मेरा बच्चा लोग. My correct one. Okay, Shraddha. Good, good, good. Anyone who's going to give me the answer? Shraddha is going for the option B here. Asif C बोल रहा है, which is 45 degrees. Saurav, hi, hello. Mohit, hi. ठीक है. Shall I explain? Explain कर सकता है ना? देख ले, everybody listen. इधर, इधर, इधर. Two ideal Polaroid sheets are arranged so that the angle between the pass axis of the two sheets is theta. Okay, we have the first Polaroid, we call it as polarizer. Second Polaroid we call it as analyzer. I have taught everything in the class. Fine. And I'm sorry. An unpolarized beam of light of intensity I naught is incident on one of the Polaroid. If the intensity of the light emerging from the other Polaroid is I naught by 4 at theta is. I'll explain. It's a very good, awesome question it is. Let me tell you. देख ले. We have two Polaroids. This is, we call it as a Polaroid itself or a polarizer. Okay. And the next one is an analyzer. Now, to the first Polaroid, a light of intensity I naught come. Whatever may be the arrangement of the first Polaroid, it doesn't matter. When a light of intensity I naught comes and passes through it, the emerging will be having an intensity of half the incident value. Matlab I naught comes, it becomes I naught by 2. Okay, whatever may be the configuration, it doesn't matter. Now, in the question it says, if this I naught by 2 passes through the second Polaroid with the name of analyzer, what comes outside is I naught by 4. Okay. Now, question is, if this is having a pass axis, if this is the pass axis, the angle between them is theta. Theta kaise? We all know the Marlow's law, right? The final intensity of the light coming, I is equal to the incoming light to the analyzer, that is I naught by 2 into cos square. This is a formula. You will be thinking, sir, wasn't the general formula I equal to I naught cos square phi? In that case, the intensity of the light approaching the analyzer was I naught. But here, the approaching intensity is I naught by 2. So it is I naught by 2 cos square phi. Okay. So here, I, which corresponds to final intensity, we know the value. How much? I naught by 4. So I naught by 4 is I naught by 2 cos square phi, right? Okay, I naught cancel 2 in 4, 2 times 1 by 2 equal to cos square phi which says cos phi is equal to 1 by root 2, taking the square root from both the sides, है ना? So if this is the case, phi का value कितना होता है? 45 degrees. Okay, I think nobody will be asking, अरे वो कैसे सर? Okay, last step तो हमको समझ में नहीं आ गया, वो कैसे हो गया सर? फिर cos phi is equal to 1 by root 2, फिर phi का value 45. अरे cos 45 is 1 by root 2. जिसको पता नहीं है ना, इतना मारूंगा मैं. So कोई भी doubt है क्या? In this particular question, any doubts? Any doubts? आप तो राइट आंसर दिया, बढ़िया बात है. आसिफ है ना? ओके, बढ़िया बात है, बढ़िया बात. तो नन्नू मुन्नू क्वेश्चन समझ में आ गया सबको? बोल दो. हाँ सर, हाँ बिल्कुल समझ में आ गया. Okay, just like two names are given, we all are humans, right? So we are given different names so that we can identify ourselves. Similarly, all are Polaroids. So the first Polaroid, उसका नाम polarizer. Second Polaroid, उसका नाम analyzer. Third Polaroid, उसका नाम है कुछ भी. Okay, so names are given ऐसे. I hope you understood. Okay, fine. Moving to the next one. Very simple. Nannu, Munnu. What do you say? Polaroid. Actually, this question should be coming before the last one, right? Because the second question is the continuation of this one. Tell me, a ray of light of I naught falls on a Polaroid, which means the first Polaroid, which is polarizer. What happened? The intensity of the emergent ray. Array, the light ray which is falling on the first Polaroid will pass through the Polaroid, and whatever is the light ray emerging will have half the intensity, I naught by 2. है ना? ठीक है. Intensity half हो जाएगा, I naught by 2 हो जाएगा. समझ में आ गया, है ना? बोल दो, हाँ सर समझ में आ गया, अच्छे से आ गया. Any doubts? No, right? Because this one I already have explained, not a big deal. अगला क्वेश्चन पे जाएगा. क्लॉक भैया कहाँ से आ गया? भैया जी आप कहाँ से आ गया? भैया जी कहाँ से आ गया आप? क्लॉक विल बी लाइक, तंग मत कर ले सर मुझे. Answers? I hope you do all remember the concept of Brewster's angle. Those who were there in my class, I have already explained. Answers? Who's gonna give me the answer? Arey nannu munnu answer hai. Okay, I'll just tell you. Many of you are having the confusion with Brewster angle kya hai sir. I'll explain. देख ले, this is the line of separation between two medium, one with refractive index n1 and refractive index n2. Okay. Now, let's say a light is coming and getting incident on the line of separation with an angle of incidence of I. We know that none of the medium is completely transparent or completely reflective. So what happens is some of the light rays will be reflected back, okay, and some of them will be undergoing refraction. So Brewster angle is defined as, it is the angle of incidence. It is the angle of incidence for which the reflected light ray is perpendicular to the refracted and the reflected is plane polarized. So after reflection, if this reflected light is plane polarized and if it makes an angle of 90 degree with the refracted light ray, okay, that angle of incidence at which these two conditions happen, we call it as Brewster's angle. And we know tan of IB, tan of Brewster angle is equal to N2 by N1. Brewster angle का value कितना दे दिया 60. So tan 60 is equal to N2 by N1. Tan 60 is root 3, which is equal to 1.73. Question is to find refractive index of 2 to 1, N2 by N1. N2 by N1 we have, go to the left, 1.73 मिल जाएगा. So हमारा correct option है 4. Doubts any? कुछ भी नहीं है suppose, right? बच्चा लोग जागो, बच्चा लोग जागो, जगने के टाइम आ गया. So ये सब याद है ना? I hope you do all remember all these concepts. सब don't forget. I think I took this particular chapter 1.5 months before, not so long away, right? So you should be remembering all these concepts. Anyway, let's get started to the next one. अगला concept आ गया. Start doing again. The question is about Brewster angle only. Yes, sir. No doubt. Right, Vipu, good. Awesome. So, shall I do this? Everybody, listen, dekh le bachcha log. Find the Brewster's angle of a wave transmitted from a medium of permittivity 4 to a medium of permittivity 2. Permittivity epsilon. So initial epsilon is 4 and it is moving to a new medium of permittivity 2. In that case, what is the value of Brewster's angle? And we don't know any direct formula connecting Brewster's angle to permittivity. But anyway, let's start writing the formula. Basic formula क्या है Brewster angle का? Tan of Brewster's angle is equal to N2 divided by N1. Refractive index of second to refractive index of first. How will you expand refractive index? That is C divided by velocity in that medium by C by V1. C cancel kar le. We will have a V1 by V2. What is V1 and V2? V1 is the velocity of light when it passes through the first medium, and V2 is the velocity of light when it passes through the second medium. Now, we all know the formula to find out velocity of any radiation when it passes through a medium. Formula is 1 by root of mu epsilon, where mu is the permeability and epsilon is the permittivity. So V1 I'm going to write it as, or I'll write it here, 1 by root of mu epsilon 1 the whole divided by V2, 1 by root of mu epsilon 2. Why I haven't written mu1 and mu2 here, bachalo? Because nothing is being talked related to permeability. So we'll have to assume permeability is remaining as a constant. So it's only the permittivity which is changing. Okay, mu cancel kar le, this epsilon 2 goes up. So this will be root of epsilon 2 by epsilon 1. So this will be equal to epsilon 2 kitna hai? 2. Epsilon 1 4. So root of 1 by 2. This is equal to 1 by 1.4 something, almost 0.7. ऐसे कुछ आ जाएगा, isn't it? 0.7 कुछ आ जाएगा. So tan of IB का value है I'm writing it here मेरा बच्चा लोग, और let's write here. Tan of IB का value मिल गया 0.7. What can you comment regarding the value of IB? Because we don't know any formula of tan of IB is 0.7. We know tan 45 का value 1 है. For an angle of 45, tan 45 is 1. But here the value is lesser than 1, which is 0.7. So the angle of tan will also be lesser than 45. Which one is that? A bit lesser than. So 35. Okay, that's how we choose the angle from it. Because if we know tan of some theta, tan of IB, if it is equal to √3, we can say IB is equal to 60 degrees. But here tan of IB 0.7 हमको नहीं पता है. So we need to compare actually. Okay, and we'll get the answer as 35.26. Not a big deal, है ना? बच्चा लोग, not a big deal. Awesome, all good. हो गई ना बात? डाउट्स कुछ है तो बता. So no doubts? Full of happiness? Are you all having the smile on your faces? चेहरे पे है क्या? Because smile and happiness always comes when you understand and when you solve a problem in your life. So if that smile is there, then it's awesome. I can simply move to the next one. The next question right in front of you. So whoever's concept related to interference is great, you'll be all doing this problem. Okay, this is a multiple option question, right? Or multiple answer question. More than one option is correct here. So you can say all the options which you find it as correct. Let me see the first person who is going to correct this. First person who is going to give me the correct answer. Let me see. हाँ हाँ, आपका स्माइल बहुत अच्छा लग रहा है. It looks good. Okay. So हो गई बात. Anyone with the answers? कोई है क्या? Asif 1-4, Asil 4, Sunita 3. Okay, I'll tell option B and D, Dr. Sahil. Okay, देख ले. Two sources S1 and S2 of intensity I1 and I2 are placed in front of a screen. Okay, the pattern of intensity distribution, we have two different sources, right? And those two different sources are having the intensity of I1 and I2. Okay, now in this case, which of the following statements are true? Matlab, if these two sources of light which has intensity I1 and I2 is producing interference pattern, if that's so, which all statements are related is true here? Let's go through one by one. We'll come to this at last. We'll go to the second one. S1 and S2 should be having a constant phase difference. Yes, that is a condition for the interference pattern to happen, right? Matlab, these two sources should always be maintaining a constant phase difference for interference pattern to happen. Yes. S1 and S2 should be having same phase? No, that's wrong. It should be having a constant phase difference. Constant hona chahiye, right? Difference in phase, it should be a constant. It is not necessary that both of them should be having the same phase all the time. This has to be correct. This is not a necessary. Okay. S1 and S2 have same wavelength. Yes, that is another condition for interference pattern to happen, or another condition for any two sources of light to be called as coherent. Okay. Now we'll go for the first one. Now, देख ले. If you look into the graph here, बच्चा लोग, right? A graph is being plotted. On the x-axis, we are marking the distance of the points from the central bright. This is a screen. Can you all see? ये हमारा screen है. So this is marked as x, the distance from the central, right? Central point is given as 0 here. This point is given 0, and when it moves to the up, this is considered as positive and this is considered as negative. On the y-axis, intensity is being plotted. Okay, now you can see that exactly at the center we are having the maximum intensity because central bright is being formed. After some distance, we are having 0 intensity. So obviously what should be happening there? Destructive interference. So we can say that देख ले, net intensity होता है ना, net intensity is 0 wherever destructive interference happens. Wherever destructive interference is happening, net intensity of light is 0. Tell me, how can I write the formula for finding net intensity if waves of intensity I1 and I2 undergo destructive interference? Formula: root I1 minus root I2 the whole square. Two light waves of intensity I1 and I2 undergo destructive interference. The formula to find net effective intensity is root I1 minus root I2 the whole square, and iska value is 0, isn't it? देख ले, wherever destructive interference is happening, you can see that it is touching the x-axis. मतलब the quantity on the y-axis, which is intensity, 0 है. मतलब net intensity wherever destructive interference happens 0 हो गया. इसका मतलब ये क्या है? This can only happen when I1 and I2 are equal. So S1 and S2 have same intensity. So yes, the first option is correct. All good? इधर तक आ गया? बोल दो, आ गया तो आ गया, सब समझ में आ गया सर, अच्छी तरह से आ गया सर. एवरीथिंग इज सुपर डुपर वाला क्लियर, राइट? सुपर से ऊपर, ऊपर से भी ऊपर वाला क्लियर, राइट? ऑफ कोर्स इट इज. एनी डाउट्स यू हैव बच्चा लोग? थोड़ा भी नन्ना मुन्ना डाउट है तो पूछ ले. I'll be solving it out. Okay. Sahil, guys, show some love. Okay. Sahil, others may think that I have paid you something, okay, and you are just promoting me. Okay, I have no personal connection with Sahil. So just because of his love, I think he might be doing that. Anyway, thank you so much. ओके, सो आपका 6 पैक, हाँ हाँ हाँ, बिल्कुल बिल्कुल, आप इंतजार कर ले, वेट कर ले, ठीक है? फाइन. नेक्स्ट वन, नन्नू मुन्नू क्वेश्चन. आई एम एक्सपेक्टिंग द आंसर within seconds, let's say. Quickly go for it, everyone. Okay, I'll explain. Array, this is a very simple, beautiful question. I'll say that. Consider the diffraction pattern for a small pinhole, diffraction pattern, as the size of the hole is increased. Hole matlab slit. So, if you are increasing the slit width, what will happen to the size and intensity? Okay, first we will write the angular width or the angular size formula, that is lambda by A. We all know that. Now, as the size of the hole, matlab if the slit width A is increased, what will happen to the size of the bands, the size of the fringes, size of the central bright band, any band, let's say you take, what will happen? As it is inversely proportional, this will decrease, isn't it? Yes. Second part, what will happen to the intensity if we increase this slit width? If we increase the slit width, what will happen to the intensity of light or intensity of diffraction pattern that is being formed here? Very simple. देख ले, if we increase the size of this hole, if we increase the width of the slit, more light will be coming. More light मतलब more light energy. More light energy का मतलब intensity तो more है. So more intensity of light is coming, which undergoes in diffraction here. Obviously, right? The effective pattern of diffraction formed will also be having larger intensity. Okay, because the superposition happens between those light waves of larger intensity. So the effective intensity formed will also be larger in that case. Not a big deal, है ना? Isn't it? More photon, more intensity. Yeah, there is no point of going to photon part and all. You can easily say if the hole is increased, if the size of the hole is increased, more light will be coming. More light energy का मतलब क्या है? More intensity. So the light waves with more intensity undergoes diffraction. So the diffraction pattern formed will also be having large intensity there. Not a big deal. Nannu munnu question. है ना? Next one. For this, you should be simply using the common sense. That's all you need here. Because the answer is super simple, let's say. I'm going to say that this is a super simple. I'm here, okay? Don't think that मैं भाग गया बाहर. Anyone? I really want to see, right? Who can give me the correct answer first? Okay. देख ले, I'll answer. First, let us go through the question, right? What do you all say? हाँ सर, हाँ बिल्कुल. एक बार क्वेश्चन पढ़ ले आप and explain भी कर ले, right? That'll be so great for us. Isn't that what you're telling? ठीक है. Young's double slit experiment, right? Double slit experiment मतलब two slits. Okay. The source is white light. One of the hole is covered by a red filter. मतलब a red transparent paper is used. That's all. And another by a blue filter in this case. I'll explain. Double slit, source of light is white. So white light is coming like this. It is the white light which is coming to both the slits. In front of this slit, what we are keeping? A transparent paper of red, and in front of this a blue paper is kept. Tell me, when white light passes through this, the emergent light ray will be of red color, and this will be having an emergent ray of blue color. They'll undergo superposition here. Now tell me, will there be an interference pattern formed here? No, because we already have explained for the formation of proper interference pattern, the light waves which is undergoing interference should be coherent. To be coherent, they should be having same wavelength and frequency. Lekin this red light and blue light are having different wavelength. So this will not come under as coherent sources. So will interference pattern be formed here? No, bilkul bhi nahi. Interference pattern is not formed. So which option? Option 3. There shall be no interference fringes. Okay. Fine. Every one of you, all good? Sahil, Asif, yes, the correct answer is 3. This sir is handsome. Okay, thank you. Means a lot. Okay. So I don't think anybody is having any kind of doubts there. isn't it? Everything is clear, I suppose. So I'm just moving for the next question here. Here we have the next one. Do this, not a big deal. Actually, we have done a similar question or similar kind of questions in the first class of wave optics, which was done on this Sunday. We couldn't complete the class, right? But anyway, we did these kind of problems. Whatever 3 or 4 questions did was based on this concept. So try to remember, close your eyes and remember, ye hai to aise. Okay, right? Try to think in that way by using the concept. Do it. Give me the answer within no time. Okay, bye bye, Gulam. There was. Okay, what is your doubt? Shoot your doubt, whatever it is. Anyone have an answer or what? Asif 2, Vipu 3. Okay, anyway, I'll explain. Okay, बच्चा लोग इधर full concentration here. The intensity of light emerging from the two slits are in the ratio 1:4. Okay, let's say the intensity of light coming from the first slit is I1, the intensity of light coming from the second slit is I2, I1 by I2, that ratio is given as 1:4. Okay, a ratio of intensity of the minimum to that of maximum will be I minimum to I maximum is the question. What is I minimum and I maximum? Arey bacha log, right? Whenever lights which is coming, or let's say in double slit interference pattern, right? Okay, interference will happen. Whenever interference happens and wherever constructive interference happens, we have the maximum intensity formed, right? That is I max. Wherever destructive interference forms, that is called as I min or minimum interference, minimum intensity. Now, the ratio of I min to I max is asked here. For that, we should be knowing the formula. What's the formula to find out the minimum intensity formed during destructive interference when light of intensity I1 and I2 interfere? Light I1 and I2 interfering each other, right? Formula of the minimum intensity formed is root of I1 minus root of I2 the whole square by I max root I1 plus root I2 the whole square. Root I1 is proportional to 1, so root 1 minus I2 proportional to 4, root 4 divided by root 1 plus root 4 the whole square. Root 4 is 2, 1 minus 2 minus 1, 1 plus 2, 3 whole square, 1 by 9, final answer, option B, not a big deal. Okay, are the concepts coming back to you? Are you getting all those things that you have learned from the wave optics chapter? Anyone can join this class, Bharat. If you are there in YouTube, okay, you can be a part of this. Good then, Asif. Good to know that you gave me the correct answer. Yes, you gave the option 2, right? Awesome. What happened? Sahil gave me the option C. Sahil को क्या हो गया? Sahil कैसे? So ये तो मिल गया, right? Concept is clear. कोई भी doubt है तो जल्दी पूछ ले. And I think you all have copy down. Copy किया ना? Copy कर ले, 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 copy कर ले. Na 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 na. Read the question. try to understand in your own way and start doing the problem. Okay, I'll start doing after 15 seconds or 20 seconds. And those who complete the answer in the meanwhile can keep on giving me the answers in the chat box. Fine. And don't think that the moment I start doing here, you should stop doing from your place. No, don't do that. Those who are not having any idea of doing this problem, just listen of whatever I explain. Others keep on doing it until I complete. Okay, if you are not able to do still after the class, you can just rewind and listen to my explanation, right? That's what you do. Anyway, there you go. Light of wavelength 6.5 into 10 power minus 7 is made to incident on two slits 1 millimeter apart. Matlab it's a Young's double slit experiment. Okay. Distance between the slits छोटू d का value भी दे दिया. The distance between the third dark fringe and the fifth bright fringe on a screen distance 1 meter from the slits will be. I'll explain. These are the double slit. This is the screen. Let's say here we have the third dark point and the distance to that I am marking it as y3. Okay, this is the third dark. And let's say here we have the fifth bright point and let's say I am marking the distance to that as y5. What is the question? Question kya hai? Question is to find out the distance between the fifth bright band and the third dark band. This distance is being asked. So how can you find that out? If I mark this as some x value, x will be how much? From total y5 from this much distance, right? Subtract this total distance which we have marked it as y3. Any doubt in that? No. So y5 is the distance to the fifth bright band. What's the formula to find out distance to the fifth bright band? Yn is equal to n times lambda capital D by D. This is the distance to the nth bright band. Here we are talking about the fifth bright band. So n will take 5. So it is 5 times lambda capital D by small d. Fine. This is the distance to the third dark band. Formula to find out the distance to the nth dark band, n minus half lambda capital D by small d. Isn't it? We are talking about the third dark, so n will take 3. 3 minus half is 5 by 2, right? So 5 by 2 lambda capital D. 5 minus 5 by 2 is 5 by 2 lambda capital D by small d. Okay, so start substituting. 5 by 2 lambda ka value is 6.5 into 10 power minus 7. Capital D ka value, how much is it? Distance between the slit and the screen, 1 meter. Can you see here? 1. The whole divided by distance with chotu D, distance between two slits, 1 millimeter apart, 1 into 10 power minus 3. So yes, that's it. We got the answer, and once we do this, कितना मिल रहा है मेरा बच्चा लोग? 6.5 divided by 2, that will be 3.25, isn't it? That will be 3.25, and into 5 by 2, so yes, हमको मिल जाएगा 1.625, right? 1.62. Yes. A small mathematics was there, but I hope you all got it. Suhani, I'm confused. Why you have to be confused, मेरा बच्चा लोग? Confused क्यों होना चाहिए? Be happy, enjoy your life. Yes, Bharat, this will be super helpful for you because you know the chapter wave optics, how important it is. You're a dropper. आपको पता है, 1 or 2 questions will come for sure. So yes, why waste time? Come and join the class, whatever you have left with. So any doubts, anyone? If nothing is there, we can jump just to the next one. Okay, so let's jump then. It's time to jump. It's time to jump. किया है हम jump. Okay, to the next one. What is the Brewster's angle for air to glass transition? Air to glass. Jaldi se, everyone can do it. Let me see who's the first person to give me the answer here. कौन है करोड़पति? First person, Asif is going for the option 2 here. Anyone else? Okay, so I can see the answer from Asif Khan, which is a 56.31. Let's see whose answer correct hai, or is it some other option which is correct. Okay, everyone keep on doing. I'll just explain. The Brewster's angle formula. Tan of Brewster's angle is equal to refractive index of the second medium to refractive index of first medium. Light is moving from air to glass. So glass is the second medium and uska refractive index is 1.5. Air, usually we take refractive index as 1. So I will write tan of IB ka value 1.5. But chalo, we know that tan 60 is root 3, which is 1.73. So if the angle is 60, tan 60 is 1.73. Here the value is a bit lesser than 1.73, which is 1.5. So the angle IB will be a bit lesser than 60 here. So, right? So the IB value will be equal to a bit lesser than 60. The only option is 56.31. And that's how we have the second one as our correct answer. Any doubt for this? No, right? Because it is a usual question, a simple question, or we can say it's a direct question, right? Good afternoon, Global. Good afternoon, everyone. So, ready for the next one? Next one, this one was very simple. Which of the following pairs denote coherent sources? Right? You can see different options are given here. Right? Among all the options, which one corresponds to those coherent sources? Which sources corresponds to coherent sources? Time to answer. Shreya Kumari, you're back. Good to have you here. No mentee and all, right? It is yes, just question solving. Everyone, quickly, shall I explain? Okay, Sahil, Bharat, going for D. Asif is also going for D. Raghav is going for option C there. Okay, so I'm able to see a mix of options. Let's discuss. 2 pinholes, okay, matlab 2 slits in front of a broad sodium lamp. 2 holes we have as say, right? Here we have one single source. So the light to both the slits are going from the same source. So obviously both of them has to be what? Coherent itself. Because both the sources of light are one and the same. Obviously it's coherent. 2 pinholes in front of an identical sodium lamp. Obviously same case. Broad sodium lamp, ideal sodium lamp, different, kuch bhi nahi. So this one is also Responding to the above case here, yes, we can say it's coherent. Two pinholes in front of a laser beam. Yes, instead of having this sodium lamp here, we are keeping laser beam, and the light will be passing through both the slits. So whatever is the light passing through both the slits, it is coming from the same source. Matlab, light passing through both the slits is same. So it's coherent, obviously. Because for coherent, what all should be same? Frequency same होना चाहिए, wavelength same होना चाहिए, and phase difference constant होना चाहिए. So obviously all these conditions will be satisfied if both the light passing through the slits are one and the same. Frequency same है, lambda भी same हो जाएगा, phase difference constant भी रहेगा. Right? Everyone? No doubts, I suppose. Simple, nanu munu questions, right? हाँ sir, बिल्कुल simple, nanu nunu. Okay, so moving on. Fine, to the next, and let's call it as the last question of today's class. Okay, so this question is also related to coherent sources, right? Okay, I can read the question for you. Dekh le. Question is actually, two sources of light are said to be coherent if light waves produced by them have same. What all things should be same for two sources of light to be considered as coherent? Two sources to be coherent, what conditions to be satisfied? What all? Frequency and a constant phase difference, right? It should be having the same frequency and a constant phase difference. If this condition is being satisfied, right? If this condition is being satisfied, we can say what? Yes, we can say that both of them are coherent, simply, right? That was not a tough question. We can move to the next one then. Here we go. Next one. So try solving this. Let's call this as the last question of today's class. Okay, the final and the last question. Raghav A, Ajay A, Ria A. Okay, everybody have given the answer for the previous one. Okay, anyway, let's see ये question कैसे करेगा. In Young's double slit experiment, okay, the distance between the slits is reduced to half. How can you write the distance between the slits? D dash became D by 2. The new distance between the slits, wo to half the initial value, and the distance between the slit and the screen, D dash, that became 2 times the initial value. Okay, so what will happen to the fringe width? Tell me, what is the general formula for fringe width? Beta equal to lambda capital D by small d. Isn't it? Yes. So question is, what is the new fringe width value? Beta dash. In which case, when following changes are being made. So in the equation, just apply those changes. Beta dash is lambda. Wavelength is not changing. D, the new D value will be equal to 2D. The distance between the slit and the screen. Small d dash. What happened? It became D by 2. ये 2 ऊपर हो जाएगा. 2 into 2 is 4 times lambda capital D by 2D. So देख ले beta dash, which is the new fringe width, is equal to 4 times lambda capital D by D is the initial fringe width, right? Yes. So we can see that the new fringe width became 4 times the initial fringe width, isn't it? And that was the last question. बोल दो सेशन कैसे था, सबको मजा आ गया, सबको समझ में आ गया without having any troubles? This is too easy, right? Good to know that. So I hope you all have enjoyed the session, because we did almost 20 to 25 to 30 almost questions, right? Okay, that was awesome. And it was so good to have every one of you here. Now, if you feel like having some scholarship when you join your college time, okay, or here the Unacademy is providing for that also with the Unacademy Prodigy scholarship test. You can write for that and you can actually win a scholarship worth up to 20 lakhs. So don't miss this opportunity. The last Prodigy exam is going to happen on Feb 27 from 12 to 1 p.m. You can enroll for free and the code is AMB10. Use this and you can enroll into Unacademy Prodigy program. Fine. So these are the class 11th batches, class 12 batches. I think this will be more helpful for you. You can come and join. Okay. Now this is the special class timetable. I'll be soon sharing it with you all people. Super awesome features of special classes are there will be a real-time interaction will be there, questions tab, live polls, leaderboard, everything is going to be there. Now offer is going on. If you go for 3-month subscription, extra 1 month will be given free only for the first 500 subscribers. Don't miss your chance. Fine. Okay. Now, धन्यवाद मेरे बच्चा लोग. Thank you so much everyone for being here. Okay. And this is a time for every one of you to show some love. You can just move your cursor and click on the like button and do let me know that you have enjoyed the session and you want more and more sessions like this. ठीक है? So I'm going. आप सब लोगों का भैया जा रहा है. Okay. So bye everyone. See you all in tomorrow's class. Till then, bye bye. Take care.